Our planet is warming. This is not a drill, it is a reality. Scientists warn of rising sea levels, extreme weather events, and mass extinctions. The culprit, greenhouse gases, primarily carbon dioxide released from burning fossil fuels. The need for solutions is dire. One controversial proposal involves mimicking volcanic eruptions by releasing sulfur dioxide into the atmosphere. This idea stems from the observed cooling effects after major volcanic events. These eruptions release sulfur dioxide, which forms sulfate aerosols in the stratosphere. These aerosols reflect sunlight away from Earth, causing a temporary cooling effect. Could we replicate this process intentionally to combat global warming? The potential is there, but the risks are substantial. This is a form of geoengineering, a deliberate, large-scale intervention in the Earth's climate system. The implications are vast and largely unknown, raising serious ethical and scientific concerns. As we grapple with the urgency of climate change, we must carefully consider all potential solutions, even those that seem radical or risky. The future of our planet may depend on it. The idea of using sulfur to cool the planet isn't entirely new. In the 20th century, we inadvertently conducted a massive, uncontrolled experiment. Leaded gasoline, widely used in vehicles, released sulfur dioxide into the atmosphere. This, combined with industrial emissions, contributed to acid rain and other environmental problems. However, these sulfur emissions also had a cooling effect. They acted as sulfate aerosols, reflecting sunlight away from Earth. This unintentional geoengineering masked some of the warming effects of greenhouse gases. The extent of this masking is still debated, but it highlights the powerful influence of sulfur compounds on our climate. This period serves as a cautionary tale. While sulfur emissions did have a cooling effect, they also caused significant environmental damage. This underscores the importance of thoroughly understanding the potential consequences before embarking on any large-scale geoengineering project. The use of sulfur dioxide for climate cooling is highly controversial. Proponents argue that it could buy us time to transition to a low-carbon economy. They point to its potential to quickly reduce global temperatures, mitigating the worst effects of climate change. The technology is also relatively inexpensive compared to other geoengineering proposals. However, critics raise serious concerns. Releasing sulfur dioxide into the atmosphere could have unintended and potentially catastrophic consequences. It could disrupt rainfall patterns, leading to droughts in some regions and floods in others. It could also damage the ozone layer, which protects us from harmful ultraviolet radiation. Furthermore, this approach does not address the root cause of climate change: greenhouse gas emissions. It is merely a temporary fix, a band-aid on a gaping wound. If we were to stop injecting sulfur dioxide into the atmosphere, global temperatures would likely rebound rapidly, with potentially devastating consequences. To understand the potential effects of sulfur dioxide on climate, scientists often look to volcanoes. Major volcanic eruptions, like the 1991 eruption of Mount Pinatubo, release massive amounts of sulfur dioxide into the stratosphere. This forms sulfate aerosols, which reflect sunlight and cool the planet. After the Pinatubo eruption, global temperatures dropped by about 0.5 degrees Celsius for a couple of years. This event provided a natural experiment, allowing scientists to study the complex interactions between sulfur aerosols and the climate system. However, volcanic eruptions are transient events. Their cooling effects are temporary. In contrast, intentional sulfur dioxide injections would need to be continuous and carefully controlled to achieve a sustained cooling effect. This level of control is unprecedented and presents significant technological and governance challenges. Section 5 experts weigh in risks and benefits. The scientific community is divided on the use of sulfur dioxide for climate cooling. Some experts, like David Keith, a professor of applied physics at Harvard University, argue that it could be a valuable tool to mitigate the worst effects of climate change, particularly in the short term. He stresses the need for careful research and responsible governance to minimize potential risks. However, other experts, such as Alan Robock, a professor of climate science at Rutgers University, are more cautious. He points to the potential for unintended consequences, such as disruptions to rainfall patterns and damage to the ozone layer. Robock emphasizes the need for a comprehensive assessment of risks and benefits before embarking on any large-scale geoengineering project. The debate highlights the complex ethical and scientific considerations surrounding climate engineering. There is no easy answer, and the stakes are incredibly high. Section 6. Population growth, amplifying the challenge. As we grapple with climate change, we must also address the underlying issue of population growth. The Earth's population continues to rise, putting increasing pressure on resources and amplifying the impacts of climate change. More people mean more demand for energy, food, and water. This in turn leads to increased greenhouse gas emissions, deforestation, and other environmental problems. Addressing population growth is crucial for achieving long-term sustainability. This is a sensitive topic, often fraught with ethical and social justice concerns. However, it is a conversation we must have. Solutions may include promoting family planning, empowering women, and ensuring access to education and healthcare, particularly in developing countries. Section 7. A global imperative: collaboration for climate action. Climate change is a global problem that requires a global solution. No single country can solve this challenge alone. It requires international cooperation, collaboration, and a shared commitment to reducing greenhouse gas emissions. The Paris Agreement, adopted in 2015, was a historic step in the right direction. However, more needs to be done. We need stronger commitments, swifter action, and a greater sense of urgency. This includes investing in renewable energy, improving energy efficiency, promoting sustainable agriculture, and protecting forests. It also involves fostering innovation and developing new technologies to address climate change. Section 8. Ethical considerations, weighing the consequences. The prospect of intentionally manipulating the Earth's climate raises profound ethical questions. Do we have the right to interfere with the planet's systems on such a massive scale? Who decides whether or not to deploy these technologies, and how do we ensure transparency and accountability? Furthermore, the potential benefits and risks of geoengineering are not evenly distributed. Some regions may benefit more than others, while some may experience adverse effects. This raises concerns about fairness and justice. These are not easy questions to answer. They require careful consideration, open dialogue, and a commitment to ethical decision-making. We must proceed with caution, recognizing the potential consequences of our actions. Section 9. The path forward. Research and innovation. While the use of sulfur dioxide for climate cooling remains controversial, it highlights the need for research and innovation in climate solutions. We need to explore a wide range of options, from carbon capture and storage to renewable energy technologies. Investing in research is crucial for understanding the risks and benefits of different approaches, as well as for developing new and innovative solutions. This includes research into geoengineering technologies, but it should not come at the expense of pursuing other, potentially safer climate solutions. We need to approach this challenge with a sense of urgency and a commitment to scientific integrity. The future of our planet depends on our ability to find effective solutions to climate change. Section 10. Conclusion: a complex equation. Climate change is a complex problem with no easy answers. The potential use of sulfur dioxide for climate cooling is a prime example of this complexity. It offers a potential solution, but one that comes with significant risks and ethical considerations. As we navigate this uncertain future, we must proceed with caution, guided by science and a deep respect for the planet and all its inhabitants. We need to explore all options, from reducing greenhouse gas emissions to investing in research and innovation. The stakes are high, but the potential rewards are even greater. By working together, we can create a more sustainable and equitable future for all.